Hey guys, Casey here. Welcome back. You're tuning in to another episode of Lions Den Investments and Reviews. Today is Thursday, October 15th. Hope you guys are having a good day. Look, I just wanted to shoot another video here on Hedera Hashgraph. I know a few videos back prior, I shot a video, and it was just kind of a quick, brief opinion, I guess, of what I thought Hedera Hashgraph was. And boy, was I wrong because I went in and did a deep dive on Hedera Hashgraph just recently, and decided to go ahead and put a presentation here together for you. And again, like I said, the video I shot previously was just an opinion for the most part, and I was reading off an article, and the more I peel back the layers on Hedera Hashgraph, I just feel like I owe you guys another video because you deserve much better than that from me when it comes to explaining how something works or doing a review on something. So here I am again shooting another video on Hedera Hashgraph and the blockchain differences, okay? So starting out, what is Hedera Hashgraph? It's a data structure and its associated distributed ledger consensus algorithm that's using two different techniques to reach consensus. Okay, and consensus would be the trust algorithm within the blockchain. It uses gossip to gossip protocol and something called virtual voting. Now, it was developed by Lehman Baird, who earned a PhD in 2016 from Carnegie Mellon. It's patented algorithm. Um, Basically, he decided to patent the technology on Hedera Hashgraph, and this one here is kind of a red flag for me because why would you patent a software in an open source space, right? Um, so that's kind of a red flag. He patented the algorithm on Hedera Hashgraph. Hedera is an intellectual property of Lehman's company Swirlds. And guys, a lot of the information I'm getting from this is from his company Swirlds. Okay, so he goes in and he explains how Hedera Hashgraph works. Um, it's also similar to IOTA, which would be the Internet of Things applications, in that it doesn't use a blockchain, but instead has its own data structure. Uh, Hedera is referred to as a DAG, meaning directed acyclic graph, and we'll go into that later, and I'll explain how that looks and how it works. And it is the public version of Hashgraph technology. Hedera is now you know gossip to gossip protocol is super fast. Okay, it confirms anywhere between 500,000 to 600,000 transactions per second, or so they claim, anyways. It spreads messages across a network, and it works in a private permission based setting. So, if you see right here, down in this picture, you've got like a node 1, node 2, node 3, 4, and 5, and they all talk with each other. So, at random, they'll spread messages and gossip between each other. And these nodes, I'll getting further into it here a little bit later. They store what they call events. Okay, so it's not a blockchain. It doesn't have blocks like a blockchain. Instead, it stores events, and these events can be stored through a timestamp, for example, which might tell you who, what, and where the message came from. Um, Now, in this example here, I've got some pictures that I took from the website Swirlds, which is Lehman Baird's company, and it kind of gives you a good representation of how this all works with Hashgraph and the messaging for gossip to gossip protocol. So, in this example, there's four members, right? You got members A, B, C, and D. Now, each member starts by creating an event, which would be just a small data structure in its own memory, represented by the gray circles here that you see below. Now, each member repeatedly calls others at random to sync with them. Okay, so like down in the first picture here, you got members A, B, C, and D. Members B and D go ahead and start talking with each other and doing uh, creating an event or spreading a message. And This is completely at random. Now it's not probabilistic. I'm sorry, it is probabilistic. It's not deterministic. So again, it's completely done at random. Each leaf has two members, and you know, so in picture two, you've got member B talking to member D. In picture three, D stores that event and then shares it with B again, and then it just goes on and on and on, like what you're seeing here. And all these different members start gossiping and storing events and sharing that information across the network. Now, each event looks something similar to like what you've got here. You got your timestamp, like I was talking about. It could hold transactions. It could hold whatever as far as data. And then you've got the hash down here below under the transaction. Now, the next step in this gossip to gossip protocol is what they call rounds, and it's basically a way to organize events. All right. Each round, as you can see in the picture, you might have like 4 rounds, like seen here, and then it'll just keep going to round 5, round 6, round 7. But basically, it's just a way for them to organize the events. A child never has a round created before one of its parents, so as time flows upward in the diagram, the round created can only stay the same or increase. The next step in this gossip to gossip protocol is something called famous witness. Famous witness is one that's used multiple times. Okay, the more often the event is passed or has been passed, the more it can be trusted. Once you have a famous witness, you can have an election. So for each witness, we need to determine if it is a famous witness. So for example, we will determine if the witness B2 is a famous witness. In this example, you've got B2 right here. This is done by considering the witnesses in the next round. So the fame of B2 will be determined by first considering the witnesses A3, B3, C3, and D3. It gets really confusing, guys, so I'm not going to go too far into it here, but just know that the more often the event has been passed, the more it can be trusted, okay? And therefore, it basically allows the gossip to gossip protocol to choose on a famous witness. Now, Hashgraph has what they call a Byzantine fault tolerance, okay? Hashgraph is an asynchronous Byzantine fault tolerance and is not deterministic. Byzantine fault tolerance basically is a property of a system, and a system is said to be Byzantine fault tolerant if it can continue to operate even if certain participants drop out or are adversarial in nature, okay? If one transaction reaches 2/3 of the network ahead of other transactions, it is considered to be first, and this is what allows it to be, makes it faster when it comes to confirming transactions. Thus, TTS throughput should not be compared with public blockchains like Bitcoin or Ethereum. Uh, Basically, Bitcoin only does like 10 transactions per second on average. Now, who is using Hashgraph, right? First off, I found a company out there. It's called VMS Software. Um, and basically, it says they will use Swirl's Hashgraph technology to allow customers to quickly and securely implement next generation distributed applications. Okay, so it says they will use. So I don't know if they're actually using it right now. If you've heard anything of this, leave comments in the description below. But basically, VSI customers, which I think are a part of the VMS software, include world's most mission critical systems such as stock exchanges, international banks, global retail chains, manufacturing, government systems, power plants, and transportation companies. Okay. Hedera also has a governing council, so it'll be governed by a group of leading corporations and organizations across multiple industries. They will vote on validity of transactions, making it not completely decentralized. Basically, it's what they call a delegated proof of stake. I actually kind of like this a little bit. I'm more of a decentralized type person. I like the fact that no one person can have control over the network. So for me, I mean, I'll have to look into this delegated proof of stake a little bit more, see how that works, um, later on. So they also aim to offer three different things. Okay, one is a cryptocurrency allowing for microtransactions. Two is a micro storage on a distributed ledger, and then three is the smart contracts. Now let's get into the blockchain real quick and the differences with public versus private, so you can kind of know the difference between Hashgraph as a technology versus blockchains. Um, so you've got a public and private when it comes to blockchains, and I've basically just broken it down into a table here according to features. So with a public, when it comes to the access feature, it's open. It's read-write access to a database. Anybody can basically access it. Okay, and then you've got private blockchains, which are permissioned read-write access to a database, and the identity is known, which basically Bitcoin solved this issue. Okay, and it prevents civil attacks from hackers taking over a blockchain. Public, the speed is slower. Private, the speed is faster. The security, when it comes to public, is proof of work and proof of stake. Okay, proof of work would be like mining um, transactions to get a reward on the blockchain through the token. Proof of stake would be like staking your tokens and getting a reward that way. Private blockchain security is pre-approved participants. Then you have the identity for public, which remains anonymous. Private identity is known identities. Okay. Public asset. Now, what is an asset, right? You might be wondering what the feature when talking about assets for blockchains. What is an asset? So in public, you have a native asset, and this is basically native tokens model, uh, an asset fundamental for the functioning of the blockchain to reward transaction validators. Okay, so just remember that. Remember that when we're talking about native assets. Then you've got private blockchains, and the asset on that would be any asset. Now, moving on here on public blockchains, like I said, you got proof of work, proof of stake. Uh, in a public non-permissioned setting, aka a public blockchain like in Bitcoin, the nodes participating in the consensus protocol are not known beforehand, and this makes them untrusted since any node can be allowed to join or leave the network at will. Proof of work solved this, so confirming transactions by mining. Just think of that as a proof of work, and that makes it trusted. Okay. In private, which is a permission distributed ledger, on those type of ledgers, identities are on all nodes and of all nodes are known beforehand, and the network is not open to arbitrary participants. The prior knowledge of the identities of the participating nodes provides a natural protection against civil attacks and makes it easier to reach consensus. Um, so there's no need of proof of work in this private permission distributed ledger. So yeah, I mean that's a mouthful there. Um, that's basically it when it comes to Hedera Hashgraph and what I was able to capture as far as how it works. Um, Now the conclusion that I've come up with here is if and when used in a public setting, Hashgraph will face the same issue that other public blockchains are facing today and may not be able to maintain security and performance. Okay, because it is a private-based permission setting that Hashgraph is operating in, um, with its algorithm. So yeah, I mean, it's yet to be known if that actually works in a public-based setting. And now, as far as private-based, it's a completely different story. They're already testing that, and I believe that VMS software company is actually already using it. Correct me if I'm wrong there. Scalability is still an open problem for blockchains, public blockchains that is. Ethereum uses POS for their Casper protocol, Neo employs DBFT. EOS has a DPoS based solution, and Ziliqua implements what they call sharding. So all of them have their scalability problems, and these are the kind of technologies they're using to try to fix that scalability issue. All these solutions have their own benefits and weaknesses, as basically there's no silver bullet to solve the scalability problem. And if you're wondering what scalability is, it's basically the number of users, number of transactions, size of the network. Uh, Basically, what it comes down to at the end of the day, guys, is can the network agree on the order of transactions, okay? So the network can maintain itself and grow and expand on its own basically over time. If so, then the network is basically what they call secure and trustworthy, and that's the big problem that a lot of public blockchains and Hashgraph are facing today. So this remains, again, to be seen in a public setting with Hashgraph, um, but yeah, that's it. So now I'm over here on the Hedera.com website. So if you want to look into it, look at more information on who's involved with it, um, and who's governing the the council for Hedera. Just go to the website here. Here's some of the big names for leading organizations that we were talking about: Boeing, Google, IBM, LG, Tata Communications, um, Deutsche Telekom. There's some big names in there, so it does have a lot of potential. But again, you got to think when you're looking at these leading organizations, they're corporations, they're centralized networks. So of course, what are they? What are they going to be? Permission-based settings. They're not open to the public, meaning nobody can just come in and access Google's networks. Okay, uh, I mean, they've got a customer-based network, but when I'm talking about from like a business perspective, so internal operations for the company, that sort of thing, IBM, all these companies are centralized and permission-based. So if you want access to their internal networks for their operations and how they work, you're going to have to get on board with them and become an employee. Um, so it's a permission-based setting, of course, meaning that Hedera, being permission-based, is probably going to work with these. That's why I'm saying it has a lot of potential. But that's essentially it for this video. If you guys like the video, hit the like button down below. Subscribe to the channel. I'll be shooting videos in the future, taking deep dives on reviews for investment products, financial services, overall stock markets, investing tips. When it comes to investing, you name it, I'm going to try to cover it, okay? But with that said, you guys have a good day, and I will talk to you later.